Well, hello there, my little calculus students. How is everyone doing today? Good, fantastic. Today we're going to be talking about a very interesting subject. This is, if you had me for pre-cal, if you had another pre-cal teacher, if you experienced anything in pre-cal last year, you know we left off at trigonometry. We actually did trigonometry second semester. Now, if you did not take pre-cal, if you're one of my IBers, no worries, because most of these things you've already heard of from geometry and the likes. We've got 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. And you know that these are all related. These are your 6 trig functions for your triangles. You know that sine is your y values, cosine's your x values, tangent's y over x or sine over cosine. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So most of that stuff you already know. Now something that is going to be a little bit different that we have not yet done is take a derivative. Take a derivative of a trig function. So today we're actually going to be talking about trig, piecewise, and absolute value functions. Now keep in mind that these are just very general rules I'm going to give you. We're going to go over specifics and look at some really interesting examples when you actually get in class, okay? And I'm going to try and slow this section down a little bit, give you a lot of time to work on things in class. All right? Let's get started. There are certain things in calculus that you are just going to have to remember. Like you're just going to have to do them, right? You're just going to have to memorize them. These 6 are those things. Primarily sine, cosine, and tangent, but I have seen some questions where cosecant, secant, and cotangent were brought up. But you absolutely must memorize the derivative of sine x, cosine x, tangent x, and I would say that you must memorize the reciprocals, cosecant, secant, and cotangent. Remember, those are your reciprocal functions. I will say that you must memorize those, but it's not going to be nearly of the same importance as sine, cosine, and tangent. Okay, so it's going to be extremely important that you memorize these derivatives. Now, these derivatives were actually found graphically. If you remember at the beginning of the year, we graphed the sine wave, right? The cosine wave, the tangent wave. You know, it's a tangent line and an asymptote. I'm going to show you the dance of that sometime. So anyway, getting into their derivatives, there are certain things that you're going to have to just memorize. Now, these derivatives were found graphically. If you graph sine x and then you mark off its slopes at every point and you graph it, the derivative of sine x is cosine of x. Again, the derivative of sine x is cosine x. The derivative of cosine x is a negative sine x. Now, these two are where a lot of people get lost at because they forget that to go from cosine, you have to put a negative in front of sine. You can go from sine to cosine all day, but to go from cosine to sine, derivative-wise, got to have that negative in front. Okay? So then you go to the tangent of x. The derivative of tangent x is secant squared x. Secant squared x. And again, these were found graphically. Cosecant of x. The derivative of cosecant x is negative cosecant squared x. The derivative of secant x is secant x tangent x. And you're multiplying those together, secant x, tangent x. And then the derivative of cotangent x is negative cosecant x, cotangent x. These will always be the same, and we do need to memorize these, especially sine, cosine, and tangent. Again, I have seen questions from an AP exam where they did use cosecant, secant, and cotangent. but it's far less compared to sine, cosine, and tangent. Those are the absolute musts. You have to memorize those. So just in case, to prepare, you always know I like to be prepared. I'm going to say memorize all 6. It's only 6 of them, so you should be fine. Now, if you notice, there's only a front and back page here, so there's going to be 2 examples of derivatives of trig functions. And then on the back, we're going to get into some absolute value and piecewise functions. So example 1, given f of x is x squared cosine x, find f prime of x. Yay! Okay, so I want to point out something really quick. X squared and x. This is x squared times cosine of x, right? There are 2 functions being multiplied together. When you have 2 functions being multiplied together, that means that you are going to have to use your product rule. Let me show you what that looks like again. First times the derivative of the second plus second times the derivative of the first. First do second, second do first. We're going to have to use that here. So it's f prime of x, and if you want, you can go ahead and write this down. The derivative of the first prime, this is x squared, so the derivative of that is 2x. Second equation prime, the derivative of cosine x is negative sine x. And then fill it in. So it's first d second. So it's x squared times the derivative of the function is a negative sine x plus second cosine x times the derivative of the first, 2x. First derivative second plus second derivative first. It's a power rule, or it's a product rule. Okay. The way you recognize a product rule is it's really simple. It's 2 things being multiplied together. You've got x squared is a function, cosine of x is a function. So then simplify. F prime of x is going to be negative x squared sine x. Just multiply those together. Your negative can go out front. Plus 2x cosine x. Let me address something really quick and listen very, very carefully to me. When you are multiplying cosine x and 2x, this is not 2 cosine of x squared. You don't multiply the x's together. Cosine of x is its own function. So the 2x, just bring it out front, okay? Example 2. Oh, and that's it, by the way. Can't simplify anymore, so why try? Example 2 says differentiate f of x is secant x over 1 plus tangent x. Ooh, this is fun. Right off the bat, I see a fraction here. Forget the fact that it's negative, or that it's secant and it's tangent. I mean, you can take the derivative of that easy just by looking up here, and we will. So remember, it's top and bottom, so you're going to be taking the derivatives here. This is the quotient rule. If you have forgotten what the quotient rule looks like, it's this guy right here. Bottom d top minus top d bottom over bottom bottom. Bottom bottom. It got a big bottom. It went from 1 bottom to 2 bottom. It's going to be a big bottom. Anyway, so what I like to do is top prime, bottom prime, just to kind of get everything straight. What's the derivative of the top? Look back up at your functions in the top. What's the derivative rather, of secant x? The derivative of secant x is sec x tan x. Make sure you put that c in there, please. Secant x and tan x. The derivative of the bottom, well, that's The derivative of 1 is, wow, just had a wicked deja vu. Still having it. My goodness, you're all here to experience this. What a phenomenal day. Still having it. That's insane. The derivative of 1, sidetrack Sally here, derivative of 1 is nothing, so that'll go away. Derivative of tangent x, look back up at the top, the derivative of tangent x is secant squared x. So f prime is going to be bottom d top. Bottom times the derivative of the top minus top d bottom. And that's all over bottom squared. Bottom, bottom. Big ol' bottom. Let's take a step to simplify here. If we multiply this out, this will be secant tangent times 1, which is secant tangent. Right? Secant tangent is one term, so that's times 1 is secant tangent. Secant tangent times tangent, secant tangent times tangent. This is kind of like saying 2x times x. Multiply tangent, tangent, you get tangent squared. So it's going to be plus secant x tan squared x minus secant times secant squared. Secant, ooh, wow, not squared. Secant times secant squared is secant cubed x. All over 1 plus 10x squared. Okay. Now remember, once you get to the calculus test, if you come across a question that is only asking you to find the derivative, which will be really rare in the free response questions, I really don't think that would happen. Just asking to find a straight derivative, and that's the only thing they want. Usually it builds off of that, like, okay, now find the slope of the tangent line, find the tangent line, blah, blah, blah. It usually builds off of that. So if you're getting a question like this, it's probably going to be in the multiple choice section. In that case, you're going to need to know how to simplify as much as possible. Now, you could always take out a secant x out of here, see if anything could combine or cancel out or anything like that. It doesn't in this case, so I'm just going to stop. Okay? And I believe that's all for trig. We're going to be doing a lot of these examples in class, so just kind of go with it for right now. Number 3 on the back says find the derivative. Okay. Now, if you look on the back, we've got a derivative, or excuse me, we've got a piecewise function, and we've got 2 absolute value functions. Now, I'm going to go over how to do these kind of individually here, but the principle behind piecewise and absolute values are actually the same. It's actually going to be the same. So to find derivatives here, remember that first it needs to actually be differentiable, right? First it actually needs to be differentiable. That means you have to actually be able to take a derivative. Now this may not mean that you can take the derivative over the entire thing, because remember, piecewise functions usually have either cusps, sharp corners, or they have jumps in them. But we can still go ahead and graph derivatives individually, and that's how we're going to approach it. I'm going to look at this equation individually and this equation individually, and I'm going to graph. Okay, or I'm not going to graph. I'm going to derive. Okay, so a couple of things I want to point out here. If you think about the graph of this, why not? Let's go ahead and graph. 2x plus 3 is